And welcome back, everyone. This is the Virtual Residency Workshop 2023. It's Friday, June 30th. This is the last day of the workshop, and we're very excited now to have our first session of the day. This is an intermediate level panel on research data management. Our moderator is Sandra Gessing, and Sandra, take it away and start with introduction.
Thank you very much, Henry. Yeah, it's a pleasure to be here, and it's really exciting research data management that we talk about it. I think I had a small slide, but just really with the name of the panelists and the first questions. So I can also talk about it. Yeah, research data management. Why are we talking about it? So it's so important, we know, with the data intensive research, but also with reproducibility, reusability, fair principles. So there's a lot in research data management going on, and facilitators have some challenges there. With this, I would shortly introduce the panelists. So Megan McCracken from University of Wisconsin-Milwaukee. Then Abhishek Mukherjee, as I said, I apologize already for maybe pronouncing some names not correctly. Please introduce yourself then again. New Jersey Institute of Technology. Chris Paolini, San Diego State University. Vas Vasiliadis from the Globus team, and Daniel Frunzenu from Texas Southern University. So we have a really nice different locations, diversity in the panel. And I gave them for the beginning 4 questions. So when they introduce themselves, I start with these questions, and that is, what is your best success story with research data management? What are your most critical challenges in research data management? What key issues should CI facilitators be aware of with research data management? And what kind of tools should CI facilitators be familiar with for research data management? And with this, we start just in the order, in the alphabetical order. So Megan, take it away.
Right. All right, happy to start. Let me go ahead and share my screen here. Did that? Okay. As I was introduced, Megan McCracken. I'm a computational research facilitator at University of Wisconsin-Milwaukee. Kind of fun, interesting fact, just to kind of get to know me. I am a PADI dive instructor, so something I do in my free time. But outside of that, so I guess I'm also fairly new to this field. I just started with Milwaukee actually last year. So getting more on my feet and kind of working with all of the different tools and everything. So anyone who's like new this year or like just getting into things, I probably have a little bit more things in common with you. But do we want to go directly into the questions, or
Yes.
do you want to? Okay, directly into the questions. Perfect. So the first thing, the first question was like a best success story for research data management. And right now we currently in Milwaukee have basically built out a brand new cluster for our researchers. And currently we are working with a team that pretty much weekly is working with 40 terabyte packets of data that they are constantly bringing into our cluster. We actively set up a new A100 GPU node for this to kind of aid in the constant or speed up, I guess, the data transfer and everything like that. And we're also constantly adding new members to that team to help. And it is a lot of work, I suppose, to constantly manage a larger group or an ever-growing group and make sure that everyone is aware of what things they need to follow. But this has been our best success story that I have worked with at Milwaukee. So, and then I'll go to the next question. Some critical challenges that I have faced and likely other CI facilitators will face as they're working with their universities. So every lab, every group that you're working with is going to be completely different. And there's going to be a multitude of needs, different types of data, different sizes of data, different speeds that they need to work with. So I think one of the biggest challenges to work with is just kind of making sure that whatever the solution you come up with, that it fits the needs of the researchers as well as effectively manages their data and the research, as well as keeping up with working with other researchers as well and making sure that they have the space that they need. All right, so kind of going from critical challenges to key issues that you'll need to be aware of, or that I've found that I've needed to be aware of, because each group, each need is going to be completely different. It's good to kind of know what previous solutions have been within your institution, and what kind of facilities you are working with. Since every university is going to be a little bit different, every group is going to be a little bit different, you want to make sure that whatever teams or whatever researchers you are working with understand what you have available and what solutions you can provide to them that may not be what they've seen previously. And I guess another thing that I've found that I like to be aware of is being able to provide and kind of effectively explain what the issues are, or what our university can provide compared to what they might be used to, that sort of a thing. And then always, if you don't have a solution or aren't sure what the solution might be, reach out to your network. Everyone here that is within the network can really be helpful as a resource. And then finally, just tools of the trade. So things that you want to be able to work with. One thing that I found that I needed to be aware of, be able to work with effectively, is your file storage system. Obviously, you want to be able to work with that and effectively manage it. So be aware of what that is within your system. For HPC, HTC, know your scheduler, whatever that may be. And then also whatever the applications are that your researchers are working with, kind of be aware of those. So MATLAB ICC, GROMACS, any of those, just kind of make yourself aware of what might be asked of you to kind of manage or to be aware of. And then also, because everything computation is happening faster and faster, GPU acceleration, those sorts of things are going to be very helpful to be aware of and understand. All right, that is those first four questions and kind of an introduction to myself. I will go ahead and hand it back to Sandra.
Thank you very much. So for the next step, I think it got a little bit lost. I thought the intro would be only 4 or 5 minutes, 3, 4, 5 minutes. But so maybe the next one can make it a little bit shorter with the question that we can get into the discussion. That would be cool. So the next one, yeah, Abhishek. Thank you. And if you are talking, you are muted. Abhishek? Does anyone hear him? Not that it's me.
Oh.
Okay. Abhishek?
Can you hear me, guys?
Yes, I can hear you now.
Thank you. Okay, so hello everyone. I'm Abhishek Mukherjee, and I've recently joined as research computing facilitator in New Jersey Institute of Technology. So my main responsibility is to maintain the updated scientific software stack on the HPC cluster, and also provide the guidance to the students or the users how to use that software effectively, and also prepare the documentation, training modules, and workshop to train the new users on how to use HPC Linux systems. So about the research data management, before that, just want to elaborate on my introduction. So just before that, I did my PhD on New Jersey Institute of Technology, and my main research was doing computational fluid dynamic analysis on tsunami flow through the flexible vegetation. So I just 3 months ago, I joined as research computing facilitator. And about the first questions about the success story about the research data management, I can tell about from my experience, which I had having problem with the data management when I was involved in the project. Where we had to do some simulations on CFD analysis to study the drag force of blue whale, and we use our computing clusters on our Pro HPC systems provided by our university, and we have some space issues. So there are some two directories. One is a project directory, which like after certain time will be removed, the data will be removed, and another we have another systems where we can back up our data. So the problem is when we run our simulations, it's almost around takes 400 and 500 gigabyte of space, and then we submitted the paper, and then when we get the comment, so when I went back and we found that some of the data has been missed, but then what we did, we write a script so that we can only transfer the important data from the scratch directory to the backup directory, so that that data can be will be later utilized. So these are the challenges I feel that about the one challenges I feel the space issues, and we need to be aware of that, which data are backed up and which are not. So because during the paper submissions, and we might get some comments where we need to go back to our the old result data and then analyze. And then there are some challenges I'd like to talk about. See, one of the important challenges are how to store and preserving research data securely for the long term. And because we need to consider the storage capacity, backup strategies, data redundancy, and data preservation formats. And also another important factor, I guess, is reproducibility of the data, because when you publish your data, the other people needs to access your data. And this is a kind of challenging task because some of the software we use is not open source. So we cannot share, like there is will be limiting to the share of the data, and also the input, the code. So this is one of the most challenges. And also another challenge is, I guess, it's the quality and integrity of the research data, because we need to establish, as a researcher, we need to establish protocols for data collections, data cleaning, validations, and data versionings to minimize the errors. So there are different tools for the research data management. One of the, I recall that is called data management plans, which for example, data DMP tool or DMP online, which provide templates and guidance based on funding agency requirements. So we can, researcher can plan the how the data can be shared about the among the multiple collaborators. And also for the data storing, we need to be aware of what are the cloud storage availability, and also like, the data transfer tools like Globus we can use. And for the data storing, or the research data storing, we can include the data repository, for example, Zenodo, Dataverse, Figshare, and we can also use GitHub and GitLab. So these are some tools that researchers needs to be aware about. And for the data encrypt, and sometimes the researcher may need to encrypt the data. So in that case, they can use GNU-PG and VeraCrypt. These are some encryption tools they can use. So that's all from my introductions and the key challenges of the research data management.
Thank you so much. So, we heard already from two people about, the challenges, different aspects, different. So if you have a question in between already, please raise your hand, or just, type in the chat. So otherwise, if there's not directly a question, we continue then now with Chris.
Hello, everyone. I'm a faculty member in the Electrical and Computer Engineering Department at San Diego State. I have a PhD in computational science with an emphasis in computational thermodynamics. So I work every summer at LBNL, Lawrence Berkeley Lab, Advanced Numerical Algorithms Group, and we do exascale GPU and OpenMP accelerated simulations of reactive transport pore scale flow. So this is with micrometer resolution. I primarily use Frontier and NERSC's Perlmutter supercomputer. So just a little bit about me. I've received 5 NSF CC awards. We have an active CC compute. We received a CC storage, and I had a CCNIE for developing a science DMZ. Also, we have had a cyber infrastructure MRI and a CI team grant. So with regard to the questions, the best success story I've had was acquisition of 2 separate 2.4 petabyte storage systems, one funded by a CC storage and another by a CC compute. These allowed us to store very large terabyte scale data sets from doing reactive transport simulations. We had a critical need to be able to store very large files and also generate large data sets in parallel using MPIIO and parallel netCDF. So we're running a lot of storage bound simulations where the time was really restricted by the amount of time it took to write data. So I guess our best success story was getting these petabyte storage systems. The most critical challenges in research data management I found is enforcing HIPAA, administrative, physical, and technical safeguards. On our systems, we have a lot of researchers that do human subjects research. They collect data from people, medical data, and that has to be protected, of course. It falls under HIPAA rules, safeguard rules. So we have to make sure that researchers are diligent about encrypting what's called protected health information, PHI. And we have to make sure that the systems are never breached. That's a big problem if PII data is exposed to the public. It's a major problem. So facilitators really need to understand how to manage protected health information to ensure that their organization remains compliant with the HIPAA security rule. What issues should facilitators be aware of in data management? Again, they should be aware of what ciphers are recommended for HIPAA under NIST 852. It covers what's needed for strong transport layer security. I would also want to say that people need to be aware of what backup systems to use. You have to routinely check that your backup system is working. We use Bacula, but you have to monitor the logs. You have to make sure there's no errors. I recommend doing spot test file restores to make sure it's working. And you need to back up the backup files to some tier 3 like cloud storage. So that's very important. Next question, which kind of tools should facilitators be familiar with? Again, GNU PG, GNU Privacy Guard was mentioned. That's necessary for encryption of protected health information. Also Globus for doing large data set transfers from supercomputers to local university systems is important. People should be familiar with rsync for mirroring and backing up their data. And of course, we all use SCP, but it has limitations. It has, overhead of encryption, which may not be needed all the time. So I would say when to use SCP and when not. And of course, Bacula again for doing backups, backing up your data, and then backing up the backups. We use rclone to back up the Bacula backup files to Google Drive and OneDrive. So that's another important tool that CI facilitators should be familiar with. Okay, that's all I have, Sandra.
Great, Chris. Thank you very much. So, and there will be more chances for, of course, all the panelists to add more information and also for the audience to ask more questions. Don't see a hand up at the moment, so we go to our next panelist. And Wes, yeah, and Globus was already mentioned.
Yeah, thanks, Sandra. Hi, good morning, everyone. Thanks for having me on the panel. I'm Wes Vasiliadis. I'm with the University of Chicago. I'm sort of the odd duck on this panel because Globus is kind of seen as a type of vendor, even though we're actually just a department in the VP of Research office. Our mission is to help all of you, help your faculty and investigators just do better, do their work better by giving them the right infrastructure. So that's really my focus. My fun fact is I'm trying to learn to play jazz piano. I've never played an instrument in my life, and it's the most incredibly difficult thing I've ever done. Please don't ask me to play next time you see me. Best success story. I've been very fortunate in having worked with literally hundreds of projects over the 13, 14 years that I've been at the university. One of the coolest ones more recently was the Arecibo telescope collapse in Puerto Rico. If you've seen Mission Impossible, you've seen Tom Cruise bouncing around on the telescope. Well, that thing eventually broke. It's been in service for over 60 years. It's collected over 3 petabytes of literally irreplaceable data, observing the skies, and it's been instrumental in a lot of critical discoveries, including some that led to Nobel Prizes. So it's data that needs to be preserved for future generations, and having a data center and an instrument that's in the middle of the jungle makes that very, very challenging. So you can read up about it, but there's some very interesting things that came together, including literally taking hard drives out of machines and driving them over to a campus that had reasonable connectivity. So you could actually pull the data from there to the mainland, and it ended up at the Texas Advanced Computing Center, and it's an ongoing process. But it that sort of ties to the third question, which is the issues. And the one thing that I will say, if I can give anyone guidance, is when you're working with folks on data management, plan ahead. Many of us tend to do the data management plans as an afterthought about 15 minutes before the proposal is due. And you say, yes, we'll maintain the data and we'll put it on a site, and we're done. Let's just get the funds. Really encourage you to think a little more programmatically about that for the long term, because some data hopefully will live for decades and beyond. Challenges, boy, there's a long list, but really the big ones for us that we're seeing right now, or have been over the last couple of years, are instruments. Instruments are eating everybody's storage, compute. If you don't have a cryo-electron microscope on your campus, you probably will soon, and I'm sure many of you have sequencers, other types of imaging devices. So the volume of data that's coming off these systems as resolutions increase is incredible, and it really does require automation. So the manual way of pointing and clicking, or taking data and moving it and managing it manually, just doesn't scale to the level that you need when instruments are involved nowadays. So automation is the big thing, thinking about how you do that in a robust way so you don't lose data. Diversity of workloads. People are running all sorts of different computations, obviously machine learning codes, many other types of codes that are very different to some of the traditional HPC codes, and having to run them on systems that are that have different capabilities, and are typically not on campus in many cases. So having to become familiar with lots of different remote computing environments is a huge challenge. And we're doing some things to help folks with that. Diversity of skill sets. The early career scientists versus folks like myself who have been around for some time. They use different tools, they have different approaches. Being aware of that, and targeting solutions that fit within the tools and processes that they're already comfortable with is kind of critical. And then compliance was mentioned, security compliance. I will say that the lawyers always say no, but collaborative research requires that you say yes to sharing. So there are ways to actually balance compliance with collaboration, and that's an area, again, we've been working on quite hard. I talked about the key issue of planning. Tooling, obviously Globus has been mentioned. Globus, if you're not familiar with Globus, happy to chat with you offline. You can find us at globus.org. ESNet is another group of folks that deal with networking and making sure that you've got the right infrastructure in place to do some amazing things with data. And I always say, without good plumbing, everything else becomes a lot harder. So with those two tools, hopefully the plumbing works, and then you can focus on research. So that's all I have. Thank you, Sandra.
Thank you, Res. So with that, we go to our last but not least panelist with the introduction. And so, Daniel, take it away.
Yes, good morning, Henry, Sandra, and everybody. So I promise I'll be short, and I'll just say my story, introducing myself. So my name is Daniel Vrencianus. I'm professor of physics at Texas Southern University, which is a small institution in Houston. So being a small institution, so the support for computing, it kind of lagged behind. So when I was hired, to start physics position, I needed to do computing, because my area is atomic and molecular physics, theoretical and computational physics. So arrived there, and it wasn't much there, so I started to build up. I got some grants from NSF MRI to build up some facilities, mainly for my own use, and so we build up some resources, and slowly expanded and offer it for other people, other researchers. So it's not a traditional academic computing environment. Is more like a shop set up for the needs of local people. So that's in terms of my challenges there. So one of the thing that I created in terms of reproducibility and collaboration for researchers, I set up a Jupyter Hub server, and that has been very popular and very useful for people at my place, from teaching classes to students, collaborating and preserving data sets, and so it has been a good experience working with that. I think it's something that people should look into and try to make it work for their own. So that's about it. So I'll let Sandra keep the timing here.
Thank you so much for your great introductions all. So we got already a set of tools everyone mentioned. So it's open for questions. I prepared also a couple of more questions, I think, which are interesting for the audience. So I see there's something in the chat. So Vinod, do you want to unmute yourself and ask the question, or should we read it from the chat?
Oh, can you hear me?
Yes.
Okay. My question is about the mixed environment and or a shared environment. How do you manage the multi-protocol like POSIX, which is used by HPC Linux systems, and Samba, which is the preferred way for the users and the lab instruments, and preserve the permissions and symlinks, etc. I mean, these protocols are quite different. So I'm wondering, do you have challenges in supporting the multi-protocol, and how do you handle it? Especially when you are backing up on very dissimilar systems like cloud and your on-prem storage systems.
Thank you for this great question. So any of the panelists volunteers to react on that?
I'll jump in. But I don't have an answer for you, because the challenge is that, especially when you're dealing with cloud systems, the metadata is obviously handled very differently and structured very differently. It's incredibly hard to maintain one-for-one matches. In fact, it's practically impossible unless you have some kind of out-of-band mechanism and storage, a place where you're storing the metadata. So it's one of the things you just have to deal with, that you either have to, after the fact, go and add metadata, or write some additional codes to actually attach, take the metadata from the original system and reflect it as best you can in the target system.
Thank you so much. Anyone else of the panelists would like to contribute some? Okay. So with that, yeah, I agree totally to Wes. It's really this translation between systems. We have done it, for example, with a project, PresQT, Preservation Quality Tool, to translate between different systems. And it's a lot of work. It's often a one-to-one. You have one boilerplate where you can do something. With that, I don't see a hand up or another chat, so I can come to my questions. So yeah, probably a lot of people have heard about the FAIR principles. So this findable, accessible, interoperable, reusable. Do you integrate FAIR principles in your research data management? Do you consider it? Do researchers ask you for that? And I just, if nobody volunteers, I will pick one of you. With that said, so nobody's jumping in. So Chris, you talked about that you already have to do a lot for HIPAA and, you know, look into that.
Right, is this regarding the question that was asked by Sumit regarding the difference between regular Globus and HIPAA Globus?
No, this is a question whether you look into FAIR principles in the findable, accessible, interoperable, reusable of data. Did you do something in that area?
Well, when you talk about reusability of data, my interpretation is storing your data sets on public repositories like GitHub. We also use IEEE data repository. There's another repository we use. So when you mean reusability of data, do you mean archiving it so that it's publicly accessible and researchers can use that data to reproduce your results? Is that what you refer to?
So yeah, so that data can be reused also from other groups, from, you know, that it's so far accessible and reusable that you can have, you know, the same characteristics of the data.
Right. So in addition to GitHub, and which everybody's familiar with, and IEEE has a data repository. There's another one I put in the chat, osf.io. This is an excellent repository. I think you have, the 5 terabytes of storage free. And so you can upload your data sets to this repository free. And what's nice about OSF.io is you get a DOI for your data, and it'll generate a nice citation in many formats like IEEE. So when you upload so you know, you're writing a paper and you refer to a data set, you can get a citation for that data, put it in your paper. I find this to be a great repository. So okay. Okay, so regarding libraries, actually, this OSF.io repository was actually is recommended for use by our librarians. That's how I actually found out about it. Does that go to your question, Sandra?
Yes, that's great. So now we have a couple of more questions in the chat also. So think a lot about FAIR data. So do any of you work with librarians at your institution to promote these concepts? So you, Chris, you gave already an answer. Maybe someone else want to jump in, whether you also work with librarians at your institution?
One more comment, if I may. Another collaboration we do with librarians is use of DMP tool. I know that DMP tool was previously mentioned, but the librarians at our university really encourage us to use DMP tool when we're writing NSF proposals and we do the data management plan. And we have a lot of, you know, when you get a successful grant, you're encouraged to make your data management plan publicly available at the university, so other proposal writers can see how you wrote your DMP, and, you know, to help them write their DMPs. You know, making good examples available publicly through DMP tool.
Cool. Thanks.
I'll
give
jump
it
in and answer. There was a question about Globus and
Yes.
HIPAA licenses. So yes, so Globus does have capabilities for managing protected data. There is a high assurance version that allows you to have sessions where people have to authenticate with specific identities from specific institutions within certain timeframes, and has all the audit trails and detailed logging and all of that that's required to be compliant. And really the big thing with HIPAA or dealing with any type of PHI is having a BAA, a business associates agreement, which the University of Chicago does sign and has signed with a lot of other campuses, so that you're covered when you're using Globus to actually manage clinical data or other data that contains PHI. So those are the differences.
Thank you so much. Does that answer the question? The global HIPAA question?
And,
Was
I also want to add something about that. You can also use Zenodo. This is a research data repository and digital preservation. So let me send the link to you where you can see the details, and which actually I use that Zenodo for preserving the data and uploading the data there. So you can take a look, and it also works as same thing as GitHub does. Like it has a versions control of the data sets, which allows researchers to update and publish the new versions of their data over time. And also it automatically linked to it DOI, which means digital object identifiers as assigned to each data set. So you can use ensuring the persistent access and citability. So I'm just use this link, post this link in the chat so that you can take a look.
Thank you so much. And any further comments?
Hi, this is Sumit from Columbia University Medical Center. Basically, we are using Globus, but we are not right now using HIPAA license. So my main concern was Globus is already end-to-end encryption. So we are not sure if somebody is sending a medical records on the Globus or not. So does it matter if it's HIPAA compliance or not? Because we don't know, it's encrypted data. So you are mute.
You are muted.
It really is a matter of policy. Most campuses that we deal with are on the side of caution and say, we don't know what data is in there. And whether you're using Globus or any other tool, I mean, SFTP is encrypted, but you don't know what data is going over the wire. So just to be safe, if there is a breach or there's some potential issue, institutions will enter into these agreements so that they have coverage after the fact. So yeah, again, it really depends on your institution and what your leadership is comfortable with.
Okay, thank you.
Yeah, so what I know from my institution, for example, Summit, is that they're always on the side of caution, because that if there's a problem really with personalized data or health data, the restrictions should be high, and if there is something like in a project that by accident it's somehow accessible, there will be big problems for the institution.
Yeah.
So therefore, I think that most institutions are very careful there.
Mm-hmm.
So with that, I go to the next question of the audience. What are the main challenges of taking applications that may run on a researcher's laptop or local premise servers to porting to HPC platforms or the cloud? Who would like to take this one?
I mean, I will say one thing that has to be handled is managing the remote computing environment that will be typically very different to whatever is on the local machine. So if your research computing center has a way of sort of packaging environments, whether it's containerizing things or whether having automated loading of the right modules, etc. I mean, that's one area where I've seen a lot of cycles get spent, people cycles, before you can actually use compute cycles.
Any further comments?
Yeah, so I just want to add, so if you want to really use exactly the same applications that you are running on your laptop, so I would suggest like use as just mentioned, like containerize. So you can use Singularity or Aptainer, and you can port the applications from there to HPC systems, or if if it is that application you're using, it's open source, and it's check that whether that is already same version is installed on the HPC. So you can also take advantage of that.
Megan, I've seen that you unmuted
Yeah.
yourself.
Yes, I was going to mention basically similar things. We also use like modules that can be individually loaded for each of the different applications, and suggest to any of our users who have like Python or something that they load up their own module for or a Conda environment that they can build themselves, which is more similar to what they might use on their lab computers as well. But yes, also Docker, Singularity are things that we employ to kind of work with, make sure that they have the same environments, but also no conflicts between other researchers' environments.
Cool, thanks. So I look around at the moment, everyone is muted. So I go to the next question from the audience. So let me, do you have any good references or tools for automating the backup process? I think one of you mentioned also backup processes. So you would like to jump again in, just unmute yourself if you would like to answer this question. Okay, I don't see anyone unmuting. Maybe the automatic backup process is something. So because backup processes itself, we talked a little bit about already, and that there must be a backup of the backup. So we talked about that. So maybe, yeah, we can follow up on this question later if we have more tools there. So there is an answer from the audience. So Matt, do you would like to describe that for a moment? The Lenovo IBM Spectrum?
Our first cluster, it used IBM Lenovo Spectrum scale, and it does snapshots. It's a parallel file system, and it worked quite well. And then our next cluster, we went to a company called Pixstore, ArcaStream Pixstore, and it basically does the same thing. They just have their own proprietary interface for you to use. And really, we wanted to go with something more automated where they were involved, so that we'd have a little more insurance. But like everybody has said in here, we also do an rsync, even of their backups, off to a whole nother storage system at our university in another building over fiber. We do a big rsync of it for mainly for a disaster type recovery situation. But that's about all I have.
Great, thank you so much.
Mm-hmm.
That is a great solution. So the next question we have is at Wes. So Globus does not know or care what type of, it jumped at the moment, sorry. It jumped. So wait, Edward does not know or care what type of data is going via Globus. What additional assurance do you provide to be HIPAA compliant?
Yeah, so we provide audit logs and very detailed trails of who has touched the data and what they've done with it. That's really all you can do. Again, this is not a Globus question, it's a general tool question. You never really know what data files contain. Sometimes file names have PHI in them. So if you have BAAs and things like that in place, if there is a breach and even that type of metadata gets compromised, then you're covered. So yeah, we've gone through multiple audits and reviews over the years. And so yeah, it just comes down to making sure you can see what was done by whom to what when. And that's really all that's required for compliance to first order, other than having end-to-end encryption and all of that, which was talked about earlier.
Okay, thank you so much. We have another question from Greta. Has anyone gotten review or comments about their data management plan and suggestions for those of us who are submitting grants either to NSF or to NIH? So any suggestion for data management plans? I know Beth, in your intro you said
I think a few of the reviewers mentioned being awarded funding, and I know in this audience there's plenty of people who do, so I didn't know if anyone has gotten specific reviewer comments that are pretty recent that could help us, as we're looking at submissions for this fall.
Thank you, Greta. So anyone in the audience or one of the panelists?
I can't speak to comments directly, so I'll let Stacy go ahead first.
Yeah, thank you. I'm actually one of the I'm a data librarian, and I review data management plan drafts that are written by researchers at my institution and provide feedback before they submit. And so I know kind of a lot about the open science concepts that they want researchers to discuss in the plans. And I was wondering if Greta had any specific questions, any specific components of a data management plan that she'd like to have information about. So I'm coming at it from the librarian perspective instead of someone who has received my own comments, but I could probably help answer some.
You probably could. So just in terms, I know that one of the reviewer comments for a resubmission, and I fully agree with it, was that the data management plan seemed pretty generic. And after you crank a few of these out, they do seem to be pretty formulaic. So how do you avoid that?
Well, I mean, they want you to, this is kind of a generic answer, I think, and sort of an obvious one that you may not be the most helpful, but they want you to think very specifically about the data types, standards, and appropriate repositories for your specific situation. So are you using a template that you created in the past or that has been floating around in your department for a while?
Well, I usually update those.
Yeah.
But the NIH repositories for genomic data, for example, are the same from year to year. So it's not like if the data types don't change and the repositories are pretty consistent, then I'm wondering what kind of language or innovation or what are they really looking for? What is it that you need to have so that the reviewers have a confidence that, yeah, you're doing it?
Yeah, sure. First of all, there may be a librarian at your institution who does the same job that I do. So you might want to contact your university library because they might have somebody who can read your draft plan and give you suggestions, just like I do for folks at my institution. But I would suggest that, for example, when you select a research data repository, you might want to go to that data repository and point out exactly what about that repository makes it a good choice. You know, do they provide, and maybe you're already doing this, do they provide a DOI? You know, do they provide robust metadata? I find that that's often the kind of detail that funding agencies are looking for when someone, for example, talks about the data repository that they've selected. But definitely contact your library, because they might have somebody that could look at your specific wording that I haven't seen. So I'm not sure what your wording says, and give you some concrete ideas.
That's really helpful, Stacy. Thank you.
Mm-hmm.
Yeah, I'll second the point about the metadata and thinking about metadata early on and somehow incentivizing the PIs to actually attach the metadata or generate it or extract it as you go along, rather than 3 years down the road, you try and figure out what that data set was from 3 years ago. Yeah, and that the metadata is really key to the whole notion of fair data. And also thinking about access to the metadata, one of the things that we've encountered in a few environments is that it's not just about protecting some of the data that contains sensitive information, you know, can be protected, but it's also protecting some of the metadata. So having different access controls for metadata versus the data. So really fine-grained, you know, I can see certain bits like titles, etc., but I can't see, you know, weight and patient, whatever, right? Those kinds of things.
Thank you so much, all. So since we are at this topic now, so what are tools for metadata or for preservation, let's say in the long run, because it's different from a backup. It's really, do you use preservation tools for data, or you recommend? And just unmute yourself if you use something. So I personally, I'm one of the co-PIs of the PresQT, the preservation quality tool, and we are really looking into, so yeah, saving a lot of the data, metadata, to have preservation tools where we work with libraries. And one of the tools we use is Zenodo, but we have also, the libraries offers preservation tools where you can have at least your data for 10 years. So the work with libraries is probably always a good suggestion when you have to preserve. So Susan had also another comment I just see. Susan, you would like also to talk about your other ideas for
No, I just chatted sort of some other ideas. We also have a data management plan review service at our institution, and I think, you know, the ideas that were shared vocally were great, and I just added a couple other things that we tend to recommend to folks submitting their DMPs to us as well.
Okay, cool. And Chris, I put your comment for everyone in the meeting because I think it by accident was just sent to me. So
Yeah, I just wanted to comment that we use the Cedar tool. There's the URL that you posted in the chat. This allows you to create metadata for your data sets, and you can export sort of a metadata description in JSON format that you can share and use in your own tools for enforcing metadata, enforcing a data set complies with the description in the JSON. Tool is called Cedar.
oh, I muted, sorry. I talked a lot. So there was another message also to Greta about that there are new guidelines from NIH, how to deal deal with the data management plan. So that is that the NIH policy change and its current guidance indicate that peer review will not see or review DMS plans, but will consider related budgets. Okay. So that is important to look at the new guidelines, because it's so exciting that NSF and NIH change all their documents in between here and then, so that everyone has to create new, not only data management plans, but also biosketches and everything. So, okay, with that, let me see whether there's something new as question in the chat. No, so I
One
would.
thing, right, Sandra, I just want to go back to the preservation question, because one thing that we've seen a lot of is people will publish their data in whatever formats they were generated in originally, or whatever they've been working with, and that are sort of suitable for current consumption, and those are not necessarily the best formats for long-term preservation. Again, if you're working with librarians, they certainly know what formats are best. But for instance, I find myself, I have a lot of PDFs, a lot of JPEGs, a lot of MP3s. Those are probably the worst formats for long-term preservation, right? For text, you really should be thinking about plain text and so on. So just think about that as well, and factor that into your data management plan, because sometimes conversion can be quite challenging.
Absolutely. We have a couple of comments here. So from Stacy, that yes, I talk to researchers about using open formats for long-term preservation every day. So, and I heard async mentioned a few times, wondering if you find async is good enough data management for backing up petabytes, volumes, and lots of metadata. So do you do the backing up is a little bit different compared with preservation, but is there any opinion about this question? Is async enough for backing up petabytes of data?
I guess I could comment on this. So using rsync, if you're not careful, it'll use SSH as a transport protocol, which introduces encryption that may not be needed if your data sets don't have protected information. I would use Globus to transfer petascale data from one petascale storage cluster to another. That would be my approach. Otherwise, if you want to use rsync, there is an implementation of SCP that uses the none encryption. You have to recompile it. There's a version out there that allows you to build secure copy with no encryption, or no cipher, I should say, the none cipher. And you can use that to not have the encryption overhead if it's not needed. It speeds up quite a bit. But for petascale data, I would think you would want to use Globus to take advantage of parallel streams during the transport. I guess that would be my approach.
Yeah, thanks for saying that, Chris. And I will just add, the other thing is with petascale, things will go wrong because it's going to take days, if not weeks, to get that data moved. And things will go wrong, and the reliability aspect is really hard, being able to restart and not have to worry about what succeeded, what failed, etc. And with Globus, you can actually do sync. There are many sync options in the service that you can specify, so you can pretty much mirror what our sync does, but get the reliability as well.
Thank you so much. We have another question in the chat from, oh, okay, Daniel. So you are asking everyone whether anybody does something with lab notebooks, PowerPoints, or group meeting notes. do we store that? How much of that needs to be shared? So if someone wants to answer on that, I can share for myself that I share, for example, PowerPoints, and the ones I want also openly accessible for people in the LinkedIn space for presentations, the SharePoint there. But other people might do something else. And I know LinkedIn is something that is proprietary, but I assume that LinkedIn is always interested in having these SharePoints still. So anyone else? Lab notebooks? So I see Stacy, you answered. Okay, it's not officially scientific data, but it's gray data. So I would say it's not research data that comes officially out of an experiment. That is true, but it's presentation data of research data, maybe. Something to consider, to share with the community. Abhishek, you have unmuted yourself. You would
Yes,
like
yeah,
to say?
just want to add something. Yeah, like we need to have some group meeting notes, and we use PowerPoints, and sometimes we use, Google Docs to keep the notes of that. And it's really important because if we doing some projects which needs which have lots of collaborators, different collaborators, and it's really important to share these notes, because we can understand that what is the discussions, and we understand our responsibility and keep track of our the project progress. So it's really important to share, to keep a track of our meetings, and like add those notes into some Google Docs, or you can use PowerPoints.
Thank you so much. So, okay, with that, I would come to another question. So how do you balance, for example, security and open access in your research data management? Because we talked about HIPAA, but it might be sometimes really that researchers want something openly accessible, but only part of it, or that after they have published it, or maybe, not everything needs to be stored. How do you deal with that question?
I guess I can jump in because we've done this in a lot of different environments, of having a way to assure that someone is at least authenticated so that you can see who's accessing the data after the fact, but not necessarily require them to jump through any additional hoops. So it's accessible, but it does require some form of authentication. That's one of the simple gates, if you will. And then I already mentioned earlier about restricting access to metadata so that you can sort of show, for instance, we have a few examples of, particularly in the life sciences where there is, healthcare or clinical data involved, where researchers might be looking for a cohort that meets certain characteristics. So you can have metadata that describes those cohorts in an aggregate way that can be accessible to the researchers, so they can search on that at an aggregate level and say, okay, I see there are, 75 records that have this type of, these characteristics in this cohort. And then you can subsequently go through additional sort of gates to get to that data. So the initial access, the initial sort of screen or search is more accessible, whereas the data requires additional controls and compliance to get to. And we do that through the Global Search Service as one example. Yeah.
Okay. So in that concept, yeah. So I know, for example, with science gateways, so I work a lot with science gateways or dashboard or virtual research environments, or you would like to call them. We give also different roads that, we give the data that there can be some parts which are publicly available. Then there's part of it that is only for the project team. So you can give, or we in science gateways, we often give them different access rights to parts of the data, and some we make really the result itself often after a publication then openly accessible. Any further comments about security versus open access? Okay. So then I come to a last question. We have 3 minutes left. So what do you care about usability, for example, in research data management? Is it important? How do you achieve that, or is it not? Is it more a little bit like an afterthought, or is it integrated in the design process of your research data management? And of course, it's a typical Sandra question because usability is one of my big topics. Sorry. So I don't see anyone unmuting. So it looks like that there is not a big opinion about usability. So that means I have to advertise that more. And or that Vas, you did unmute yourself for a moment.
Yeah, I was gonna say that I made a comment earlier in the intro about being cognizant of the diverse skill sets that people bring to the table, and you're dealing with researchers across all disciplines, where in certain areas certainly usability is kind of critical. It's sort of it becomes a non-starter to expect some people to go drop into a command line and do things, for example, right? So I guess I don't think about it consciously, but it's always like implied that you want to be as usable as possible for at least that target constituency. You can't have everything be point and click, but in some cases without point and click, no one's going to use it. So
yeah, absolutely. With that said, okay, Sumit?
Yes, I have one question. Maybe it's related to Globus, that we are backing up of our data from one site to another site. Can we do it as an admin? Can we do it using Globus? So this is my main question.
Yes, you should be able to. Maybe there are some details. There always are. I'd be happy to, if you reach out to me offline, I'd be happy to talk through the specifics of the use case with you, but you should be able to, yes.
Okay, definitely I will reach out to you.
Okay, thanks.
Thank you.
So thank you so much, everyone. We are exactly on the minute of our 75-minute panel. So thank you again to all the panelists. Thank you so much. This was a great discussion. Please, reach out to the panelists or me if you have more questions about the topic. And with that, I give it back to Henry.
All right. Thank you, Sandra, and thank you, panelists. I was delighted with the panel. I'm very happy, and I think that was clear that the audience was delighted as well. Let me go ahead and stop the recording.